Hello friends, welcome to WebTechSchool. In today's lesson, we are going to talk about given a linked list, we need to find out if the linked list has a loop or not. The given example has already a loop on it. When we will say a linked list has a loop or not, if the last pointer instead of pointing to the null, if it points to any other node. Like consider another example where let's say we have 1 points to 2, 2 points to 3, and 3 points to null. So this is our single linked list. So in a single linked list, so instead of pointing to null, if 3 points back to 2, so this is nothing but there is a loop exist. Okay. Similarly, let's consider another example. Let's say we have 8 points to 6, and 6 points to 9, and 9 points to 4, 4 points to let's say 10, and 10 points to 11, and 11 points to 9. So in this case as well, we have a loop. We need to write a function which will give back if in a given linked list, if there is a loop exist or not. Okay. For solving this, we have multiple approaches. Let's look at one by one. In the first approach, let's say this is our method 1. In method 1, we will use another data structure to solve this problem. Let's say we have a hash table. So in the hash table, what we'll do, we will keep on traversing through our linked list. So we have a reference to the head node. So every time a nodes come in, we are gonna make an entry to our hash table and with a value of either true or false. Okay. Now next element, so head points to the next one, will make another entry true, and again this will make it as true. Then we'll make an entry 3, will make it true. Then we'll make another entry 4, will make this true. Then we will make 5 and true. Then again our head will points to 6, will make it as true. Now finally 6 points to 3. So when making an entry to 3, we will check if that entry is already present in the hash table. That means there is a loop. Okay. Similarly, if we look at another example where 1 points to 2, 2 points to 3, and 3 points to 2, here also we'll take let's say hash table. So in the hash table, our head node points to 1, will push 1, and value as true will push 2, and value as true. Okay, and then we'll push 3 again, value was true. Now 3 points to 2. So while pushing 2 to the hash table, we'll see 2 already exist. That means there is a loop in the linked list. So what will be the time complexity for this? So we are traversing through each node of the linked list. So time complexity would be big O of n. Similarly, we are also using a hash map or a hash table to store our all your entries. So all the entries needs to be stored. So the space complexity will also be big O of n in method 1. Okay, so method 1 we solved it using hash table. Okay, let's look at method 2. In method 2, it's basically if we get a chance to modify the data structure or the node of a or the attributes of a given node, then also we can solve it. So what I meant by that, so in a linked list, every node object has two properties basically. One is data or the value element. It can be any data type. Okay. Another one is the next pointer node. Let's say next pointer. Okay. So in method 2, if we can, let's say, add another property called boolean is visited. Okay, then also we'll be able to solve this. How? Let's say we'll start traversing through our linked list. Once we traverse the head node, we will set for the head node is visited to true. Okay, for this node is visited value will be true. Similarly, now head will become head dot next. So for 2 also we'll set it to true, this value. Okay, same with 3, 4, 5 and 6. When 6 points to 3, we'll check if this value is already true, that means there is a loop. Okay, let's consider a small example. So let's say we have 1, 2 and 3 and 3 points to 2. Okay, in this case, what we are doing, we started with head 1 and we set is visited property to true. So this we set it to true. Now head moves to 2 and for this also we set the is visited to true. Now head moves to 3. For 3 also we set it to true. Now head moves to again 2 head dot next. Here again is visited is already true. If it is already true, that means we have a loop. Okay, so here what we did by modifying the existing data structure. Modifying the data structure. Let's look at its time complexity. So for this, we are only traversing each node only once. So that means the time complexity would be big O of n, where n is the number of node in the linked list. Now let's look at the method 3. So in method 3, what we'll do is, so let's say what is our example? So in the example we have 1 points to 2, 2 points to 3, 3 points to 4, 4 points to 5 and 5 points to 6 and 6 points to 3. This is our example, right? So in this example, let's take 2 pointers. So I will call this as one is, let's say, slow pointer and another one is fast pointer, both initially pointing to the head. Now on each step, what we'll do, we will move our slow pointer to its one value and the fast pointer up to two values or two reference. Okay, so slow pointer will be moving only sp.next, but the fast pointer will be moving fp.next.next. So let's say this is our slow pointer and let's say this is our fast pointer. After the first iteration, what will happen? Fast pointer moves to two steps. So fast pointer reaches till 3. Okay. Now slow pointer reaches only one step. So slow pointer will reach over here. Okay. Now on the second iteration, fast pointer will move two steps. Now fast pointer will reach 5 and slow pointer will move only one step. Okay, now the slow pointer will reach to 3 node. Okay, now the fast pointer will again move two steps. So and this is my second step. So fast pointer will reach to 3 and the slow pointer will reach to 4. Okay, now Again, fast pointer will move 2 steps. So fast pointer will reach 5. This is where the fast pointer will reach, and the slow pointer will reach also 5. Okay. The moment the fast pointer and the slow pointer matches, that means there is a loop exist. Okay, let's verify this with another example. So we have 1 points to 2, and 2 points to 3, and 3 points to, let's say, 2. Okay, what we will do, we'll declare 2 pointers. One is fast pointer and another one is slow pointer. So fast pointer moves to place. So after fast iteration, fast pointer reaches over here and slow pointer reaches on 2. Now again, fast pointer moves 2 steps. So fast pointer reaches over here after moving 2 steps. Now slow pointer also moves 1 step. On node 3, fast pointer is equal to slow pointer. So that means there is a loop. Okay. So in case there is no loop, let's see, look at this. So we have 1 points to 2, 2 points to 3, 3 points to null. So this is a single linked list. So we don't have any loop in this linked list. So let's declare 2 pointers. This is slow pointer and this is fast pointer. So both are pointing to head. Now slow pointer moves to one place and fast pointer moves to place. Now slow pointer moves to one place and fast pointer moves to two place, which is null. So these 2 pointers will never meet if there is no loop. Let's look at the time complexity in method 3. So the time complexity would be big O of n, where n is the number of nodes in the linked list. We are not using any extra space on method 3. So the space the space complexity would be constant space. To summarize, we have discussed 3 approaches for detecting a loop in the linked list. One is using the hash table, where the time complexity is big of n and the space complexity is also big of n because the hash table is involved. The second approach was modifying the existing data structure by adding an extra property is visited. So here the time complexity is big of n and the space complexity is big of 1. The third approach is the two pointer approach, where we took 2 pointers. One is a slow pointer and another one is a fast pointer. By moving slow pointer to its only the next reference, while the fast pointer to its next to next reference. The time complexity for the third approach is big of n and the space complexity is constant time, which is big of 1. Out of 3 approaches, the most efficient one is the approach number 3 or the method 3. Now I am in Visual Studio. Let's write our method. So private static, we are going to return back a boolean value saying if there is a loop exist or not. So is loop exist, and we're going to receive the head node. So I'll say simply list node head. Okay. Now what we're going to do? So if head is equal to null, that means the list is empty. So we'll simply return false. In other case, what we are going to do, we will declare 2 pointers. Let's say list node first pointer, and both will assign to head and list node slow pointer also equal to head. Now let's traverse through the linked list. As long as slow pointer is not equal to null and first pointer is also not equal to null and first pointer dot next is not equal to null. So what we're gonna do, we will move the first pointer to two values, fp dot next and slow pointer to a single value, slow pointer dot next. And in case if the slow pointer is equal to first pointer, then return true. Okay, so in other case simply return false. Let's verify this implementation. I have already created the example list what we have been discussing. So where we have a loop exist at node 6, node 6 points to 3. So if you look at, so this is our node 6. Now to the nodes, to the node 6 next element, we are assigning head.next.next. So head.next.next is the node 3. So we made the reference over here on line number 21. Okay. Now let's call our method. So our method is the method presents in the list operation class. So I'll just bring in list operation dot is loop exist. Okay, so let's go back and see why it's not appearing in the intelligence. So if I go back, so we made it as a private, that needs to be public. So I'll save this and I'll go back and we should get it now is loop exist. And inside here, we will pass the head node of the list and the result will grab it as a result variable. So this needs to be a boolean. Let's print this variable. So I'll simply say console dot write line. So let's say loop exist and we'll just display the result. Whatever the result value, will simply display it. Let's run our program and see if we are getting back true or false. So the expected output is there is a loop exist, so we should get true. This value should be true. Let's run this. Okay, so now if we go back and you can see loop exists true. So we get back our expected result. That is everything on how to detect a loop in the linked list. So this has few follow-up questions like now that we detected the loop, how we can now remove the loop. So we'll look that in our upcoming videos. I'll push this code to GitHub and you can find the link in description. If you like this video, please give your thumbs up and subscribe to this channel. And thanks for watching.